Hello everyone. Hello everyone. My name is Alexander Dunaev and welcome to the fourth edition of Winter Data and AI Meetup. Thank you very much for joining us today. Our today's call meeting relates to Metadata Enrichment CoPilot and automating smarter data management. And our speaker is Rakesh Kumar. He is a data solution architect in EPAM Systems. And today he will show how AI can help improve metadata management and make data easier to find and use. You will hear how automation and large language models can improve metadata quality and support data governance. The session also includes a real example of how this works in practice. If you enjoy this event, please like and subscribe to support our community. Your feedback helps us to improve for future meetups. So also, if you have any questions to Rakesh, please paste them in chat and we will discuss them after the presentation. And now let's welcome our speaker, Rakesh. The floor is yours.
Thank you. Thank you, everyone. And thank you, Alex, for setting this stage. My name is Rakesh Kumar, and Alex already introduced me. I'm working as a data solutions architect in EPAM. And today we are going to discuss about metadata enrichment copilot. As the name suggests, there are three parts: metadata, enrichment, and copilot. We are making use of the LLM for the enrichment of the metadata. And a little bit about myself. I have a total experience of 15 plus years of total in total. And in these 15 years, I have started my career as a data analyst. Then I came into big data, then cloud computing, and then I started working on Gen AI space. In these 15 years, I have been working with different industry domains: pharmaceuticals, healthcare, energy, retail, consulting, and different diverse kind of industries. And I have been working as a data solutions architect, senior consultant, associate manager, and in different capacities. Most of the time I spent my time with clients. I also these days also I spend my time with the clients. I try to understand their problem, and then I give them the best suitable solution for them. Now, what we're going to cover today is the summary. What we are going to have in this forum, that we will be covering the problem statement, how the solution looks like, who are the people who can benefit from it, that kind of summary. Then the problem that we are going to solve, how the process flow diagram looks like, the process flow looks like, and then how the whole solution works, that we will see, and then we will conclude with the closing thoughts, and then we will see that there is a case study that we have implemented for the pharmaceutical industry. To start with, let's go with the summary. And like I said, it's a AI powered solution, meaning that we are making use of the LLM, and we are automating the evaluation of the metadata, enrichment of the metadata, and the consolidation of the metadata. What it means is that you read the data, and then there is a choice that after the evaluation, that whether to enrich the metadata or not enrich the metadata. There is a configuration file where, since the intent was to have the automation, so in the configuration file, it's predefined that whether we want the enrichment further or not, and out of those enrichment, which enrichment we want. For example, enrichment of the description, business tags, business terms, data quality, and classification. So these, in later part of the demo, will cover those things. Now, there are current workarounds of this whole solution. May it be open source solutions. There are paid license versions also, but those are expensive. Open source solutions are not that much secure and comprehensive. And those solutions which are licensed, even though they give they give the solution, but we have seen that then we have to bring in another team that can create some wrappers so as to meet the company requirements. Now, having said that, the whole solution can be used by data stewards, data governance teams, business analysts, or maybe data engineers also. What we have seen so far, that making use of this solution, people have saved about 50 to 70% of their time. What they have seen is that they have consistency across the data, and that increase their discoverability. Maybe if you are using Colibra, then there is a search, global search, or the search of the metadata enhances with this solution. and what we have seen that productivity and the reporting output or the quality of the output is also increasing. So these are the benefits of this solution. Now let's talk about the problem statement. Let's start with the first one, the manual classification. Classification of the metadata, that is still a manual process, even though the tools that we have seen in the market are providing the automated classification. They the preparation for the classification itself is a manual activity, so that takes up a lot of time. We're making use of Gen AI to save that time and automatically how it can do the classification, saving thereby not only the time but also cost to the company. Now, the consistency is another problem that I was talking about in the previous slide. What we have seen that business terms, tags for the same kind of data across the department is misinterpreted. How to handle that? The consistent business terms or tags associated with the data. So that will give the proper definition, correct and proper definition across the department, thereby uh, giving them the same impression about the data and the make and the use of it, ease of bring the ease of use of the data to all the departments. Description gaps, this is, I think, all of us would have seen across the data. Sometimes we see the data description not available, description is vague, one liner description making no sense. Also, from database to schema to table to column, the description itself is not consistent. So these are the gaps that we have seen in the description part of the metadata or the data that we are trying to solve here. And then the enrichment, what we have seen that there is a team for enrichment creation of the business terms, there is a team for enrichment of the through tags etc. There is a pipeline for these things. So instead of having different things working in silos, what we can have is a complete solution that can do all these things in an automatic fashion. Now, I will skim over this diagram because we will revisit this diagram during the demo part also, but let me give you a high level overview what is happening here. On the left hand side, you are seeing a process flow, 1, 2, 3, 4 numbering. The one is the metadata extraction part. First, what it does is from the metadata repository, it looks into the metadata, and then it evaluates the metadata based on certain criteria. The decision is black and white. If the metadata is good, then there is no description enrichment that needs to be done. And then if the metadata is bad, then the first it will go for description enrichment, and then it will go for rest of the enrichment. User have a choice to choose between the four that we have: classification, tags, business terms, or DQ rules. They can choose all, they can choose one or combination of these. That liberty we have. Once we have the classification complete, then the consolidation of the data happens, and then it is ready to consume by the user. It can be saved into S3, it can be saved into Unity Catalog, it can be saved into Azure Purview, Colibra, anywhere. And there are different agents that you have that we have mentioned in the right hand side. I'm a little bit under weather, so just bear with me, having a little bit of throat pain, but nevertheless. Um, on the right hand side, you are seeing certain agents mentioned here. These are agents, not agentic AI. So the difference between agentic AI and AI agent is that agentic AI meets certain criteria of planning, decision making, memory. Those are the categorization for the agentic AI, but this is AI agent doing a specific job based on certain instructions that we will cover in the later part of the demo also. Now, how it is working. Before we jump into the demo, let's see how it works. We prepare the platform, we deploy the code. We have to procure the Gen AI API. Give me a second. We have to procure the Gen AI API, and we have the configuration file there where we mention that what are the choices we have to make for the enrichment, and then the evaluation happens based on certain criteria like completeness, clarity, consistency, presence of critical fields, and then it triggers the metadata enrichment part. And finally we have the consolidation uh, in the second last portion, and finally the final output is getting saved. Let me jump into the demonstration part. So I have already executed this code, but let me just refresh it. We will rerun it. Yeah, on the page you are seeing these are the these are the enrichment that we are going to perform, and this is the flow diagram that I just discussed. Then here is the connection string where we give the Colibra, we configure the Colibra and bring the metadata, maybe from any of the domains or any kind of asset we bring in, we fetch the metadata. In the interest of time, I will just consume the JSON. So let's see how the JSON looks like. It's a clinical trial metadata that we'll see how it looks like in actual. What you notice here is that the description of the database is lacking, very vague, and there are a lot many problems that we will see how it is getting evaluated. But let me scroll through so that you can see the metadata all in all. Then the evaluation already happened, and now we can see the metadata is bad. Why it is bad? Because of these reasons, that the title is missing, the description is bad, the vogue description is available, and likewise. So which column is having what kind of problem, all is getting um, identified here, and based on that, it is identified that the metadata is bad. Now it's a decision of the user that how he want to proceed. So right now my logical intent is to enrich the description first. So I will give a context here. This is a description. This is a little bit of documentation on the clinical trial related to the table, that database that we have. So what it will do, it will read the data, text information. Let me show you how it looks like. This is the clinical trial documentation related to the database. It will read the data from here and it will enrich the metadata. So let's see how it is enriching. We have seen that how the change happened. So see, the description is properly now mentioned for the databases, and now it is trickling down to tables, and now it is trickling down to columns. So this is how the description is getting enriched, and it is the same case for all the tables and the column respective columns. So this is the first layer of the enrichment, where the description got enriched within no second. And then we can take a decision that we have to do uh, classification or rule generation or tags or business terms generation. Now, since we have to show the features, so I have covered all the four options that we have. And while we do classification, there are certain inputs that we have to give. For example, in this case, I'm giving the criteria for classification, that it should be confidential, integrity, um, data PII, and cron something, these kind of classification criteria that we have to go with. And there is a sample classification that I have given as an example for LLM to be accurate on its interpretation. And then we can give additional context also, but I'm just keeping it blank. We can do the classification here. So bear with me. It is running on my system, so that's a little bit slow, but it will give the output. Yeah, so we can see the output of the column names, the attribute classification, the confidentiality, integrity, PII, crongel, and GXP. So all this information is getting classified in a proper manner for all the columns. It's the column level classification. And then we have the option to generate the tags. If you notice here, the tags are generated where the score is more than 85%. What it means is that whatever tags it will generate, if the confidence is less than 85%, it will not just tag, because that may be irrelevant. So we are intending to remove the garbage values, and this is most appropriate above the 85% values that are coming. So that will increase the identification of the metadata and increase the discoverability. This is the business term generation. I'll pause here, let the job run. Yeah. So what we have seen that the job has been executed, the business terms got generated. This is the syntax what is accepted in Colibra. What we have seen previously that the metadata is extracted from Colibra, and this is the syntax in which Colibra accepts the business terms. That's why you are seeing these asset type, name, description. But it is configurable. We can change it as per the need. Maybe for Unity Catalog it is different, so we can change it. Lastly, we have the DQ rules. DQ rules is what it shows is that whatever applicable DQ rules that can be applied at the column level, that it lists down, and it is not 100% correct, uh, but it needs some tweaking because some of the times the interpretation needs to be validated. So this is good to use, but it might need human interference to tweak some values or change some categories. But it is good information that DQ rules are also getting generated at the same time. For example, having count less than one, so you might want them less than 10 or something. So that on that front, it needs some changes. Uh, for the DQ rules, what it says, what it shows or brings is the rule name, the description of the rule, and the SQL query corresponding to that. It is ready to use. You can directly use the SQL query within some tool, maybe Databricks or somewhere. It is ready to use. You can use it as it is or by making some changes. Now, it also gives the information that what kind of rule is that and what are the columns involved. So this information is captured. Now we have the final output. What we have seen, the enriched description here, um, where the data description got enriched, and it is for the database tables, columns corresponding columns. Yeah. Next one is the classification of metadata that we have seen. Now the tags that got generated, it is well structured. Now you can see that all the tags are having values more than 85%, and there are business terms associated with that. The DQ rules associated with that, that is also got generated, and the usage stats. So we can see that there are 5 API calls made, and we can reduce it um, if we want, but right now it is making use of 5 API calls. In total, 14,000 tokens got consumed. That is like nothing for a GenAI application. It hardly will cost less than dollar, I guess. We can have generated this consolidated JSON. Let me show you how it looks like while it is getting generated. This is how it looks like. You will notice here that the database tags are going into the right place for the tags for the database. The description is at the right place. The tables description associated tags, and then there is a column. For column, we have the business terms, right business term getting associated at the right column, uh, the tags also, and the classification of the columns, and the business rule, or sorry, DQ rules getting associated for the right column. And the same is for all the tables and columns and databases available. So this is how the consolidation happens, and it yeah, it shows up. Now this is good to use now. If we want, we can make use of it. We can put it into S3, we can consume it, or we can put it into Colibra as per we want. But for this boilerplate application, we are making use of the S3, so we can save it into S3. So this is the UI application. Now let me show you how do the folder structure looks like. um, this is how the folder structure looks like. What I have in my library is there is a two version. One is the UI that you have seen, and there is another version that is without UI. Let me show you how the without UI version works. Yeah, so it identified the configuration that we want, all the four enrichments. We just saw that the tags got generated. Now the business term is getting generated. Now this got generated. Now DQ rules is getting generated. Yeah, this is the classification part. Now the consolidation of metadata is happening. It saved the metadata at the right place. So the one that I showed you, this is the consolidated metadata. In addition to this, let me go back to this slide. One second. Yeah, how it works, I think we have seen that. Now, let me go through the case study that we have done for one of the clients. We have the case where we have implemented it in Colibra and we extracted the metadata, put it into S3. Let me go back to presentation mode. Yeah, we extracted the metadata and we put it into the extracted metadata into S3. And then we applied this solution where the enrichment of metadata evaluation, everything is happening. And then the output, the final consolidated JSON is again getting saved in the S3, where it is again written to Colibra back. In Colibra, there is a human that is a steward that is approving all those enrichments. And then if there is a feedback, if there is a rejection, that gets logged in and that is available for further refinement. So the cycle keeps on working, and this is how it is getting enriched, improved with every cycle of the loop. And this is how we implement it for the pharmaceutical industry. So there is a notification system also implemented. Once the steward gets the notification that the metadata is available for evaluation, the notification is sent. Also, when the steward finishes the job, notification is sent. So that is how the job has been synchronized, orchestrated. So that is that part. Now, there are certain useful links that you can look into. There are, I will share, or maybe you can take a look from this screenshot. Uh, Certain enrichment of metadata available for Oracle. They have their publicly available information. These are certain research papers, and there is a sanity.io. They're also doing metadata enrichment. But this solution is a little bit different. Maybe you can compare while you read it. And I'll give a conclusion thought that with this automation, you can save a lot of time, and this automation works with UI, without UI. You can make use of proper total automation, or make an use of a human in the loops way also. So that is all. I will hand over for the questions, open the floor for the questions. If there is any in the chat, I am not able to see. If someone can read it or ask me, unmute yourself. Perfect.
Yeah, thank you very much, Rakesh, for interesting presentation. Okay, now let's move to questions. We have them many. Okay, I will just read them. So first, did you observe drifts, small or big changes for the definitions of the metadata for same set of input state without any changes in metadata?
Um, not yet, but there is a possibility to see the drift. That can happen when the landscape of the data changes. But right now the tool is not enabled to detect the drift and modify it. But that's a good input that we have implemented in a different solution, uh, that detecting the data drift and then modifying based on that. So that we have implemented in a different solution. It is not available in this solution. So that is
Mhm.
it.
Okay. Yeah, thank you. Let's move to another question. How you actually test agentic output itself for quality and absence of hallucinations? What are guardrails to prevent AI to pollute metadata with garbage on scale?
Yeah, first we did a thorough testing of this, and to handle that no garbage values comes, we maintain the hallucination and the temperature. So that way we stick to the ground, and the relevant content is getting associated with the definition where the description or the context is coming. So that way, that is one of the guardrails that we have. Other is that the quality check is happening. Maybe when steward is checking, that's a rejection or acceptance gives the information that the Gen AI is working well. If it is not working well, then the stewards give the feedback that it is rejected. So that gives the information that how it is working and what is the quality of the output.
Mm-hmm. Yeah, one more question. Did you consider generating data quality rules with great expectation format to automate data quality?
Not great expectation format.
Mm-hmm.
This is a specific requirement for the client. That's why the format that you see, that description, name, SQL query, that is the syntax that we follow. That is specific, meeting the specific requirement for a specific client. But we have not tested with great expectations.
Mm-hmm. Okay, what else we have? If we use cloud database, for example, Redshift or BigQuery, is it possible to get metadata through API and after processing write metadata back?
Uh, for Reds, I can tell you from for Databricks, Unity Catalog does saves the metadata. So Unity Catalog, we do the data governance through the Unity Catalog. So that is the way. For Redshift, I have not tested, so I'm not sure that if we rewrite the metadata back to the Redshift, then what process we need to be it needs to be followed. But I'm sure that Redshift does provide a way to do the update of the description of the data and relevant metadata. So it is possible, but I have not tested it. But based on my experience, I
Mhm.
can tell that it is possible.
Yeah, some more practical questions. Does Colibra offer comparable capabilities for metadata enrichment?
Yes, it does provide. So Colibra have AI description generator. The difference between that and this solution is that the Colibra generates a description based on the available information in Colibra. It does not consider the context out of the Colibra, meaning that if one second, if within a domain there are 5 databases, 10 tables, and likewise, so it consolidates all the information and then it will generate the uh, description. So it limits itself within the information available within Colibra. It does not consider if you give any documentation. There is no provision to upload any documentation to generate that. Other things, classification, yes, it is having a provision to do the classification, but that classification is different. This classification is different. Every company have different classification criterias, and that's where Colibra lacks it. So there is the available classification method, but not every company's requirements got met with that classification.
Mhm. Yeah,
Yeah.
one more related question. Which LLM did you use here?
It is GPT 4.0.
And yeah, a related question: is it like, do you like? Is it acceptable to send like real data to GPT?
No, no real data is being used here. We have only considered the metadata. No real data we have used.
Okay, guys. And yeah, one more question. How do you upload the results to S3? Your Python code will do it or LLM will do it? Have you
Python
used
code will do.
AWS
No,
MCP?
we have not used MCP. The Python code will upload the metadata. Maybe through Boto 3, we can configure the S3 configuration of the bucket, and that it will load. We are not making use of LLM for uploading the metadata. The job
Mhm.
of LLM is done once the enrichment is done. So after that, it's out of the picture.
Mhm. Okay. Yeah, got it. Yeah, looks like there are some more questions, but yeah, I think Rakesh will reply them in on our talk page. So yeah, thank you very much, Rakesh, for your presentation. It was very interesting. I see many questions in the chat. Yeah, thank you everyone for joining us for the first talk for this call. Yeah, if you like this call or if you like this talk, or maybe you don't like, please give Rakesh a page on the talk page. Yeah, you can also rate this talk. You can watch, you don't download the presentation, and you can watch the recording. Yeah, thank you very much. Thank you, Rakesh, for joining us. Yeah,
Thank you.
see
Thank you
you
everyone
on the
for your
next
time.
call. Bye.
Yeah. Bye bye.